Hi, good afternoon, everyone. My name is Umachandar. I'm a program manager in the SQL Server team.
Hi, I'm Nelly. I'm also a program manager in the SQL Server team.
Cool. So how many of you actually use SQL Server 2016 right now? Oh, okay, that's great. So anybody using R in there? Oh, okay, handful. Okay, cool.
Any of you using Python? Okay. Seems to be off.
Oh, I wasn't hooked up? Okay. Yeah. So this is a quick agenda. We have just one slide on what machine learning and why it's in SQL. So just to set some context for the folks who are new to this. And then we'll look at some of the features in SQL Server which are available and which is actually unique to this integration, right? And we'll go through that. And at the end, we have some resources and we'll open up for questions. Okay, so why machine learning with SQL? So we kind of look at it in like three ways. The first thing is basically the problem of moving data to wherever the compute is, right? In this case, you probably have it on your analytics server, or you might be doing it from your laptop, like how we are going to show most of the stuff. So this is actually a problem because once you have a bigger data set to deal with, how do you interact with it and build models and use them with your database, right? So that's one of the big problems we try to solve. And then the other problem is once you build the models, how do you make them available to all your applications very easily, right? So this is a challenge because if you build a model in R, for example, and you have a Java application or you have a Power BI dashboard, how will you expose that intelligence very easily to that dashboard or your Java app, right? A lot of times we find customers rewriting their code and re-implementing in their own language, right? So that's the thing we try to eliminate here. So by putting it in SQL Server, you can just use a SQL API to get to that, right? And then last but not the least, we have an enterprise scale database platform, which is the most secure platform available. So there are a lot of performance features, HA, and different configurations in which you can run SQL. So now you can leverage those with your machine learning scripts, right? So that means you can run your ML scripts on your always on secondary, for example, right? Similarly, if the database fails over, your ML script also kind of gets that failover capabilities, right? In the sense, you can run the script now on your secondaries, right? And now you can also run this on Azure SQL DB, which is the managed platform. So this is like at a high level, like the three areas by which we kind of look at it is like, how do you solve each one of these problems? And some of the patterns we're going to show here are going to touch each one of those.
I think that's the other session.
Oh, I think it's from the other session, I think. Oh, yeah. Sorry about that. Okay, so just to give a high-level idea, the integration right now, it's actually starting R and Python processes outside of SQL Server, right? So this is something we do for security reasons, and a lot of the R Python code is not something Microsoft writes. So we kind of isolate them outside the SQL Server process. I won't get into the details of the design and architecture in this, but that's just to set the kind of 1,000-foot view of the things. And then the current integration as such is more suited towards what we call batch-oriented operations, right? So if you look in machine learning, there is a concept of scoring, right? Like you build a model and then you want to say assign a risk value to a particular row. It could be like your transaction, it could be your new loan application, and those are actually single transactions. And the current one is not suited for that because you have to start the process every time and send the data, right? But there are ways to use that still. So that's what we mean by doing batch-oriented operations. And then we're going to look at what is available in the server, and then 2017 also has a new thing called native scoring, which we'll look at. Okay, first, whenever we talk about like SQL compute context, what do we mean by that, right? So let's look at a typical workflow. So you have a data scientist who's in their IDE. It could be like RStudio, Visual Studio, PyCharm, anything, right? And they want to interact with the data in the database and build some machine learning models, right? So in this case, SQL Server. So typically, you would use some data access API. I mean, that piece of code is showing like RODBC data access code, like the SQL query. And so you will run a query. It's like any other, data access API, right? Like SQL client or ODBC. So you'll pull the data, then you run the model. In this case, the function GLM, which basically builds a linear regression model. And that's all happening on the workstation, right? And then once you have the model output, which is like a binary object, you probably save it in a file. I mean, we've seen customers put them in a GitHub source and so on, right? So this is like the typical workflow. So the challenge obviously is like going back to the data movement. I mean, if you need to work with a terabyte of data, right, which is something I'll show. So then you have a problem, right? Your laptop may not work with that, or you have to find a bigger server. So now how do we make that easier and simpler, right? So you have the same scenario now. You have a data scientist, and now you have SQL Server, say 2016 or 17 on the right. And we have machine learning services installed there. So now what you can do is create something called a compute context. I mean, this piece of code looks almost exactly like your ODBC code, right? So you will set a connection string, and in this case, we use this function called rxlogit. This is our implementation of logistic regression. And so in this example, what happens is the execution actually goes to the server. So that means once you set the compute context and you say rxlogit, we actually push the rxlogit call over to the server. So that means now you eliminated the data movement, right? So now SQL Server actually runs the model on the server itself by spinning up a R process or Python process, right? And then at the end, you get the output back. In this case, it's the same blob. So to the data scientist, I mean, they're still getting the same expected results. I mean, they're not doing anything different, right? And then one of the things you can do is the functions available with the SQL integration now can actually save the results from the R script or Python script efficiently. So that's the other thing you do. So we'll show you like some reports also which allow you to easily manage these things. So this is kind of like the workflow with this one. And then, so what does it mean, right? So SQL compute context is something you can use for anything. This is specific to the Rx functions, right? So whenever you see this Rx function, that's our implementation of some algorithms which basically can run in this context, right? So the key benefits obviously are like you can push the ML compute from your client over to a big server, right? And then you are removing the data movement problem, and the other thing is you basically leverage the server resources, right? So with that, let's quickly look at a demo. Okay. So what I have here is, first we'll walk through the first workflow, right? Like where I said, like you use ODBC to kind of get the data. So this is R tools for Visual Studio. I mean, the same piece of code will work from R Studio, for example. So, I mean, typically, you connect, in this case, I'll use like R ODBC. So I load the library. Then this particular database is a database from the TPC benchmark. It's called Big Bench. It's a benchmark which has both SQL and machine learning workloads. So there are certain queries there which requires you to use machine learning to solve the problem, right? So this is an implementation of it. So there is a query here which is basically doing some SQL computations. The scenario here is you have some web click streams data of users, and you are actually trying to predict or train a model which says if somebody is going to click on a book category or not. And it's going to look at clicks in other categories and demographic information of the user and so on, right? So that's a SQL query which is going to, this join which you see here, right? So let's do this. Like this. And then I have a function here in R, which is the pattern I was telling you. I mean, you basically just connect to the SQL Server. You run the SQL query, which basically gets the data over to my laptop. It's a 1 gig one. I mean, it's not that many rows. I mean, let's go here, right? So I have like it's 6.7 million, right? Not that many. And then we'll build this model, right? So let's actually first save the function. I mean, it simply loads the function in the interactive window, and then you can run this, right? So now this piece of code is going to run it, and it's actually fetching the data from SQL Server, and it's going to run on my laptop. So this one, I mean, you can see that thread there. I mean, that's probably what the R process is running, right? So it finished, right? So it's about 13 seconds. So not bad, right? So now the same thing you can do like reverse scoring, right? So now what happens? I mean, I have another database, the same benchmark. It has scale all the way to like 30 terabytes, 100 terabytes, and so on. I have a 1 terabyte here. So let's quickly look at the rows. So this is about 12 billion rows here, right, in this table. And I actually created a sample of 100 million here, right? So that's the thing I have here.
Okay, so you see, are you going to run that on your laptop now?
Yep, yeah, I'm going to run the same piece of code against the bigger database, right? So let's come back here. So this is what, I mean, sorry, I switched. So this is about 12 billion. So if you look at let's see here. This is how big the data set is. Like it's about 360 gig, right? And this one is about 4 gig. I mean, I created a sample which is like 100 million just for, demonstration purpose, right? So now I'll come here. Now I'm going to show you the SQL compute context code, or the way of doing this without having to move that big database, I mean, that data from the database to my laptop, right? So here actually, the other thing I will do is I'll also leverage parallelism on the server. I mean, we'll talk in detail about that, but for now, let's ignore that parameter. So same thing, I have the same query, except it's on this 1 terabyte database. So now here is the difference. So you set a compute context by using this line of code, right? These 2 lines. So it's basically a connection string to SQL Server, and you say, hey, here is my compute context. And then after that, what happens is all these RX functions essentially uses that compute context to run that piece of code. So that's really what it is. So now let's actually load this function, right? And then we'll run this. And we can actually go to the server here, and I mean, we'll look in detail. I mean, this has about 240 CPUs. I mean, you're going to see some things starting here. See, that's basically your R processes. If you come here, you would see like SQL Server running, starting all these R processes. And then it's going to run. I mean, it takes about, I think, like 20 seconds, something like that. Yeah, so 30 seconds, right? So I actually trained a model on a 100 million rows data set from my laptop in 30 seconds, right? So that's really what it is. I used like 8 CPUs on that machine because my degree of parallelism for this query was 8. I mean, you could even reduce it if you want. You could, I mean, if the machine has enough memory, I mean, you could even run it with 1 thread, right? Okay, so that was a quick demo of how SQL compute context helps you to work with large data sets, right, without actually having to move the thing back to your laptop. So that next one.
All right, now let's talk about the features that are available in the SB execute external script. I don't know how many of you are familiar with that, but that's basically the stored procedure that enables you to run the external scripts when you're doing it from the server. So it's a special stored procedure, and it has a bunch of parameters which you can use as features to leverage to, for example, get better scale and performance. So what we're going to do now is that we're going to introduce them one by one. First, for you to know, like, okay, how to use them and when to use them, and some samples of examples, and then in the end, we'll go back to the compute context and talk about the features that you can use leveraging the compute context. So it's a bit complicated, but we'll try to do it one step at a time. The first thing we're going to talk about is actually being able to provide the external script, like provide it the data that it needs for training or scoring. Since the external script, either an R or Python script, needs this data, we have two different ways to provide it, essentially. By pushing the data that we have on this slide, basically means that we will push the data that you're querying, the query that you're inputting to your external script. That query is basically being loaded into data that I will show later. So the requirements for this, to be able to do this type of pushing up, this,
getting cut.
Yeah, sorry about that. Obviously means that you need enough memory to be able to receive the data that, I'm sorry, this seems to go on and off. Anyways, so this scenario, we recommend using, when you're using, for example, smaller data sets, or if you're not using these RX functions that UC mentioned before. When you're using any type of CRAN R or open source R function, this is the recommended way to push the data to the external script. But it also has some disadvantages. It's obviously bound by memory. So if your data doesn't fit in the memory, you will not be able to store it in memory or process. And then we also have another disadvantage, which has to do with concurrency. And Jussi, do you mind telling a little bit about why this limitation exists?
Yeah. So for example, if you take a data set which requires, say, a gig of memory to store and process, right? So now you want to run a model or do something with it for 100 connections which are coming to the server at the same time. So that means you would require 100 times the memory, so 100 gig in this case. So that's one of the disadvantages with this is like your concurrency will be limited depending on how many resources you have on that machine, right? So one way you could scale this is like we talked about, you can run the thing on your always on secondaries, right? So that's another way to kind of get more memory, but from different machines.
So this is to show how you would do this. How do you push your query results into the external script like this? So you have the SB execute external script, and then you have a parameter called the input data. So what you do is that you basically put the query in there, and it's going to be pushed into a data frame. For R, it's an R data frame. For Python, it's a pandas data frame. So let's take a look at a code example to see. So you see the orange text there. That's basically the input data set being used for training a generalized linear regression model in R. So it's pretty straightforward. I know that a lot of people, when they see this SB execute external script call, are a bit afraid, but it's because you have to define the parameters and so forth. But this is basically how it works. You can put any query into that, any SQL query this way and pushing it to your R scripts. And as I mentioned, this is the recommended way when you're not using the RX functions. If you're using the RX functions, which we will cover a bit later, then you can actually leverage the compute context. So what's happening here in this case is that this data is being, basically the R Python script doesn't have to go and fetch the data. We're basically serving the script the data. So if you have smaller data sets and you do some performance measurements, you would actually see that this method of pushing the data is a bit faster than, for example, connecting and trying to fetch the data. And that's because the data is loaded into their data frame not during the actual execution time of the script. Which means that you could save, for smaller data sets, you could actually save a little bit of time. Now, let's take a look at a demo. Yep. So what we're going to do here is that we're going to train using the GLM-R, CRAN-R GLM function. We're going to train a model. And what's interesting now is that I'm actually doing this, we're going to do this in Azure SQL DB. I don't know if you heard previously this week, but we actually have a preview currently for limited regions, but in Azure, we have a preview of running R in Azure SQL DB. So we thought it would be fun to show the demo there. Let's first, before I do anything else, let's start executing this, and then we can look at the code in the meantime while it's finishing off. So we have a stored procedure here, and inside this stored procedure, we're embedding this call to SB execute external script that I just showed. We have the language here, so in this case it's R. I see that this is actually the prediction, right?
Yeah.
Okay, let me show you another script then. I wanted to show you the training. Now I'm executing the prediction, so I have to wait for that. All right. So in the same way, we have the embedded external script call, and we'll call the GLM function here. It's happening here. It's a bit complicated. We'll give it the formula, basically what we want to, what it is that we want to train this model on, the variable that's what we're trying to predict. Basically, in this case, it's the New York taxi data set. I don't know if you're familiar with that, but we're trying to predict whether or not a customer will tip or not. So let me check if the other script is, I think the other script executed, so we can start. There's currently a limitation in our preview, so we cannot run several scripts at the same time. All right, so now this is performing the training. And the model that's going to be the outcome out of this, let's take a look at it. So the output here is going to be a model. And we're going to store that model in the database. Now, we also have some dashboards, some custom reports that you can use in SSMS to get a better overview of, for example, in this case, to basically do your model management and get an overview of what models do I have, what versions do we have. So this is also one of the values of doing this machine learning in database, is that you can actually just take advantage of SQL Server to do your model management to make sure that you're using the right versions when you're in production, for example, and retraining frequently. Let's go back to the script and see it's still executing here.
It takes about
yeah, and as you can see here, the whole point was that this input query, this was that we're pushing the data basically to the script, and we're doing it through this input query that I had up here. It's still executing, okay.
So one thing to note about all this compute is the CPUs which are available mostly on the cloud or on servers are actually slower CPUs than actually what I have on my laptop here, for example, right? This is the latest Kaby Lake Intel processor, so this is actually much faster than even the bigger server which I have. So a lot of times this ML thing would be bound on really the CPU and memory.
Yeah, and if we take a look at the prediction, we're storing them in a table now. So basically, we're making them available for any application to just, or Power BI report or whatever you want to use to consume them. So this is another big value, is that probably we're making all of this available to a bigger audience than previously would have access to these this type of information. All right, so now let's move on. Can we switch back to? So now we're going to talk about something that we call streaming, and this has nothing to do with streaming videos, from Netflix to SQL Server or something like that. This is purely about being able to process data in chunks. So that's what we mean when we talk about streaming. So streaming using the SP execute external script and the parameters there is mainly recommended or intended to be used for example, when you're using the CRAN R functions. This is something that you can leverage with any R function. But there's a requirement there. And the requirement is that you should not have dependencies between rows. So for example, if you're doing training, your end product is going to be a model, and the training machine learning script will need the entire data set to be able to generate the correct model, right? Because it's learning from the patterns and training on that data set. So if you would give it chunks, the model would probably not, it would not be the correct model. So when we talk about streaming in this way in SB execute external script, then we're mainly focusing on the scoring scenario, which means doing predictions. And there are some very good reasons why you should use streaming. As I mentioned, you can chunk data. So what does that mean? It means that if you have a data set that is larger than your memory can process, that means that you can stream the data. So you're basically giving the script a chance to process pieces at a time. And as I mentioned, this can also be leveraged for the RX functions, but then you would need to use the compute context to leverage that, and we'll get back to that a bit later. Let's take a look at how this streaming actually works. So we have a data set of 15,000 rows, and we're going to basically chop this in chunks of 5,000. So the script is going to get 5,000 at a time. We have that parameter, rows per read. That's how you basically say that I want to stream in this case. So you add that parameter in the SB execute external script, and you define the size of number of rows that you want to stream at a time. So we'll start sending the first 5,000 rows, and the script, in this case, why is it not?
Next, yeah.
I'm clicking next.
Yeah.
Okay, there. So the script will start to process. This is a prediction, so it's the R predict function that's going to be run, on these first 5,000 rows. And while we're executing this first batch of 5,000, we can start sending the next 5,000. So this is basically how this process is. And when when we start to process the second batch, we can send the third chunk of data. So we had 15,000, it will be 3 batches basically. And over the execution time, that's what happens. But we also have some results. So you see, how does that work with the results? How do we get them sent back? Can you explain that?
Yeah, so think of this like a multiplexing kind of model, right? Like how you kind of have conversations over the phone or something similar to that. So each predict can actually be sending data and also receiving data at the same time, the R script. So once the first chunk is sent and then the script is running, we'll be pushing data over the network buffer to the R side. And at the same time, the script can actually send results back. So SQL actually interleaves both the sending and the receiving. And then all the data finally gets accumulated on the server side and you insert it, right? So this allows you to actually process even like a billion rows data set you want to score, right? Like 1 row at a time. And you could still do it with like 100 meg of memory allocated to R. So that's basically the scenario.
Exactly. Let's take a look at, again, in the code, how would you use this? It's pretty simple. It's you have the rows per read parameter. You'll set whatever batch size you want there. You have your input query, the input data that's going to be chunked into those pieces. And in the same way, then you call the predict function in R in this case and leverage the streaming.
So one thing to note is like the R script itself didn't do anything special, right? I mean,
yeah.
that line of code is just the same thing which you would write even if you're scoring 1 row or 1,000 rows or 1,000,000 rows, it doesn't matter. But here with the SQL integration, you could just control how much rows it receives. So.
Exactly. We're leveraging the actual integration to be able to achieve this. And let's take a look at a demo of the streaming. So this is going to be a prediction scenario. Let's take a look at the data set that we're going to use. It's 343,000 something rows that we're going to stream here. So again, I have a stored procedure, and I'm giving it this query that we're going to stream the data on. once again, I hope you're starting to see the pattern here that we have the call to SP execute external script. We're going to go to the end of the script here to be able to see the parameters. So here you can see that we have defined a batch size of 100,000 rows at a time. So that's how we're going to do the streaming in this case. So let's take a look at the results here. One thing to emphasize is that this is one single process executing this. I know before it's running doing things in parallel, but this is actually running everything in one single process. And you can see that here on the output. You can see that it's the same process ID that we got back, but I did some printouts so that we could see, the actual size of each stream that we're sending. So it's 100,000 rows per stream, and since we had 340,000 something, we will have 3 streams of 100,000, and then we will have a smaller chunk in the end for the remaining. So that's basically how this works. This is also running in Azure SQL DB. So it's pretty fun that it actually is working both on-premise and in the cloud. Yeah. All right. Now, let's talk about parallel processing, because if you want to gain, let's say, the benefits of this integration, one of the key features is that you can actually run your machine learning scripts parallelized. So again, there are 2 different ways of doing this parallel execution. If you're using the RX functions, you can leverage the compute context, and then you can set number of tasks, and UC will go into depth with the parallelization on the RX functions, and so. But if you leverage parallel processing on any R script, then this is what we're going to talk about is the trivial parallelism. The reason why we call it trivial parallelism is that there's no guarantee for which rows that will go to which process. So it's basically nothing that we have control over. But if you have a parallel query plan for the input query that you're sending into the external script, and there's no dependency between the rows again, if you're, for example, you can do this on predictions, then you can leverage this. And for the function mentioned, there is another way that we recommend for leveraging parallelism. And there you can actually do the training in parallel, which is pretty cool. So this basically helps you to scale to larger data sets, scale the larger data sets, because you can get shorter processing times. You can execute in parallel. You can leverage several CPUs, and it integrates with the SQL Server parallel query execution. Now, we have a new feature in SQL Server 2017, which enables you to do batch processing on column store data, and that can actually help in this case. You see, how could that help us, the batch mode execution in this case?
So how many of you are aware of batch mode processing in SQL Server? Okay, so this is specific to column store indexes, right? Traditionally, with a regular B tree, SQL Server will actually execute each operator a row at a time, right? So in column store indexes, there is a concept of batches. So it's basically a column of data. It's about like 999 rows, right? So the advantage is this batch of data is highly compressed, right? And it's very efficient to send over the wire. So typically, if your TDS driver is querying like column store, then these batches get converted to rows before actually sending it to the client, because the clients don't know how to deal with batches. Whereas with this integration, what we can do is we can actually send the batches as is to the R side, and then we have our R library which actually converts that to the data frame. So this actually gives you like 20 to 40% perf benefits. So like on the benchmarks which we have where I showed some of these queries, between 16 and 17, I get like 40% perf benefit.
All right, so just a quick recap on the parallel processing. So how do you leverage parallel processing, this trivial parallelism? We have another parameter, it's called parallel. You set that to 1, and then the number of parallel processes that can execute is dependent on your max DOP setting. So in this case, the max DOP is 2, so we will get 2 parallel processes executing with our R scripts, and we'll send the results back for a server. Now looking at the code again, we have the parallel, down there you can see the parallel parameter, set that to 1, make sure that your query is running with a parallel query plan, and you can execute your predictions like this. Now Jussi is going to show you a demo of actually streaming and trivial parallelism at the same time.
Switch. Okay. So again, the thing to see and note here is like there is actually very few things you need to do with your R script itself, right? So many of these you could control from your stored procedure call. Like you could run, if the query runs in parallel for the scoring scenario, you automatically get parallelism. And if it runs in serial, then it's just running in serial mode. And if for some reason you want to restrict R or Python memory to less memory, then you could just enable the streaming. And so by this, like, you are not even changing your R script logic in any way, right? Okay, so first let's look at the quick streaming example which we saw, right? So this is basically just running like on a single data set, right? So the stored procedure is here. So it's the proc here, which we saw. So not many changes. I mean, this output is just what we put here so that you kind of see what's happening, right? And then this is the main call essentially. Predict is like a function in R which essentially does the score given a model and the data, right? And if it takes about, I think, 40 seconds. And the main parameters which I tune here is like this one and then the rows per read. That's pretty much it. So the rest of the input is actually what the R script needs, like the model in this case, and it's going to show some output. So this is the same thing which we have, right? So each batch, I actually scored on the entire data set, which happened to be about 1.7 million or something. So that's what you saw. So we actually ran the script over 18 streams of data. So now the same thing, what we can do is, now I'll run it in a parallel mode, right? So now we can go back to the server here. And if I come here, right? So you'll see like suddenly all these green thingies came, right? Like those are the new process which the query actually started, right? And it's actually running now, right? So we also have reports which you can go and see in terms of like, okay, what are all the sessions running? Oh, probably finished.
We have these on GitHub, right?
Yeah.
Yeah, we have the link in the end.
So here I think the thing to note, so now let's look at the process IDs, right? So there are now 4 processes running because I said DOP to 4. So the first process ID is like 36368. So that's going to get like some n streams, right? In this case, I think 5. And then you have another process, which basically also was getting some chunks of data. So here you have 4 threads running in SQL, each one communicating to a specific process on the other side and sending the data. So it's actually parallel execution of a query and parallel, scoring on the R side. So that's how this piece is integrated.
Jussi, do you have to give the hint in the query?
No. So this is more to control like how much, what is your DOP, right? On this box, it's like 240 CPU, so it's going to just like run with very, depending on the data size, it's going to run at very large DOP. So I just want to control, so that's why I specified. But otherwise, it's not really required. So here you saw the second process again got like 5 streams, and these are all again controlled by SQL Server, the query engine, and each one communicates to the R process. And at the end, all of the collection of the results also is done by SQL, and then you get it back, right? So that's why in this window, even though each of these chunks of output actually came from different processes, they're all collected, and then at the end, you just get it as if it's one, right? Similarly, the scores end up in the database as a result. So you can come here and query this, right? This big table here. So at the end, we basically inserted all of these back into this table. So that's it. So it's about like 1.7 million. That's what we scored there. Okay. So with that, let's go. Yeah, so that was parallelism, right? So now the scenario you saw there was just the scoring scenario, right? Like meaning like one row at a time. So now what if you want to actually train and build models itself in parallel, right? So that's where the SQL compute context, which I demoed from the client side, now we'll see how you can actually use it on the server side also, right? So this one enables training in parallel and also scoring in parallel, right? So in the previous scenario, you saw like all the results have to be collected and returned to the table. So now one of the things you could do is with this you could even write to different tables, right, from each one of these processes, or each one could be writing to the same table in parallel. So in that way you actually get parallel insert on the R side. So that's another thing. And then the other obvious benefit is like you can leverage all the CPUs which you have on your SQL Server machine very efficiently, right? So let's look at an example of how the training of function, Rx function works, right? So in this example, you have SQL Server with this stored procedure, and you basically have like same, just like how I showed in the query. I'll use degree of parallelism 2 here, just for illustration purpose. So now first, as the query starts, then we'll go spin up these, 2 processes here. And this BXL server which you see here, that is basically the Microsoft implementation of many of these algorithms, right? Which, can run in parallel. So now what happens is SQL, we basically send the results, and each process is going to build a fragment of the model, right? So each one is computing some results. So it could be like linear regression, it could be like decision tree, whatever, right? So each guy computes a fragment of the model, and at the end you get like one result back to the stored procedure, right? So to the end result is you still get one big object, but everything happened in parallel. So this is how the parallel training essentially works, right?
So would you get the same model if you were doing this in serial mode with one process only?
Yeah, correct, yeah. So this one, like, so for example, even if in SQL Server, there is no guarantee that you will always get a parallel plan, right? Because if there are not enough resources, the QO can switch to a serial plan and the whole thing will run in serial. So now same thing applies here, right? This is really just a hint to SQL Server to say, hey, okay, I want to run this with 4 threads. And it is possible that you get 2 threads or even 1 thread. But your output will always be the same, right? So that's guaranteed. So this is a piece of code like where it looks exactly like what I showed in the client code, and you do the compute context from the server side itself. So one thing to note here is in the connection string, again, I will just use like Windows auth, right? So this is something you don't have to worry about. The integration actually takes care of impersonating the original user. Like for example, I run it on some data set. My permissions will be applied to those connections coming from the R script. So here, that way you don't need to embed your credentials or anything. So you just use trusted connection. So this is one of the integration which we have in SQL Server. Okay, let's quickly look at the demo. So this one I'll spend more time kind of like just look at what's happening here, right? So here we'll do the same thing on this big table. Let me just go here. So I made a copy of this data for the query file. This is about what 3.1 million, right? The big table is 12 billion, so I just took like a copy of this just to run it. And then typically like you would run like 80% sample and so on, so that's what we would do here, right? So that query is just doing a simple, I'm using like table sample here with some seed value. And it's the same piece of code which you saw in the slide. You define what is called the data source. It's kind of like think of it like a table, right? So you just define, hey, here is my data, it's coming from this query or it's coming from a table, and this is what you would define. And you're going to call this stored procedure, right? And the other key parameter is like we talked about, like this one here, which basically decides how much parallelism you get. And you can set the value from outside of SQL Server. So in this case, like I kind of pass it from here, right? So you can run this, and this thing is going to run, right? So now let's come here and to this machine. Still hasn't not started, because one of the things which happens is the RX function actually does a sampling of the data to see how much is there. So that's what it's doing. That's why you are not seeing. Otherwise, the report will actually show if our script is running or not, right? Still not stored. Meanwhile, I'll show you some of the other reports which we have. So one of the things which often customers ask us is like, hey, how much memory is R consuming? How much memory is SQL consuming? And so on, right? So this is like a quick report on like on the DMVs which are already available. So it kind of shows like in this, like this server has like 4 terabytes of memory. And this SQL instance is using about a terabyte, and the peak memory usage for R was like about 225 gig, right? Which you can see here in this, like here for example, this is SQL. I have 2 versions of SQL here, 16 and 17 RTM also running. So 17 RTM is consuming less. So this is one of the pieces which we have here. So you could actually run this, and it will show you the query, right? So most of these integration is already, part of the SQL resource governor. So that way you can just leverage those to find actually how much memory R is using, how much memory your Python scripts are using, and so on. Okay, so let's see if it started anything. Not yet? Oh, maybe it finished. No, still running. Okay, so meanwhile, let's come here and look at this code. So now it's the same piece of code which I have in the SQL stored procedure. So as you can see, the details are the same essentially, right? Like you would set like compute context, you would set the data. So one of the ways, like I basically just copied this whole piece of script and put it in the stored procedure, right? So it's kind of like a lift and shift scenario. Okay, let's come back here. Is this running or not? Yeah, okay. So now it started. Oh, okay, so here you can see like actually DOP is 1 here. I think there's not enough data on this in this table. I think I had like only 3 million. So it didn't really run in parallelism. But that's fine, it'll work. Instead, we'll run this script. So that script is also running the compute context from the client, and it's going to do the same thing. It's going to basically do a sample, and then it's going to start. So now it started. So here is one of the things which happens. That one I ran with DOP 8. So this is this whole thing this is Process Explorer, which, oh man, it went away fast. It took like about 32 seconds, right? So we basically spun up like 8 processes, SQL query ran with 8, and then that's how much results you got. So now this is actually cool, right? Like I can come here and I don't know, on this machine I can set it to 64. I don't care, right? I can come here. Actually 64 for 100 million would be slower, but maybe I'll pick 32. Because there's not enough data to do 64 threads. You'll need like more than I mean like maybe billion rows or something. Okay, so then now we'll come here.
So it's very convenient, basically. So you wouldn't need to, as a data scientist, if you're used to working from your ID, you really need to change that.
Yeah.
Just like how to know how to leverage these type of features.
So now let's come here. The thing is going to start. So this is the first call coming, right? And then boom, right? So this guy, which you see here, now it basically started 32 processes, right? I mean, I'm not going to count here, but it should be 32 there. And you can see like each one of these, the memory goes. And if I come here to this report, you should see, oh, it finished.
It's too fast.
Yeah, this server is too fast. A lot of times I forget that, yeah, so it's gone. That thing finished. So yeah, so that's, so this also takes about like, I think 32 is actually slower than 8. I think for this data, see, it's 52 seconds. The previous one finished in like about 30 seconds. So I think for the 100 million rows, this is slower. So this is one of the ways you will have to tune your DOP, right? Depending on your data set. You will have to say, okay, I mean, do I want to run this with 4? Do I want to run this with 8? Do I want to always run this with 4? I mean, so that's the tuning you would typically do. So these reports are available in GitHub. I mean, that's something which we encourage people who are using the integration to use because this gives you like a very high level overview of a lot of these. And you don't need to know like, okay, which DMV should I query to go find how much memory R is using, which DMV do I need to query to find if somebody is running an R script, like in this example, right? Is it doing something? Is it waiting for I/O? And so on, right? So those are the details which are available here.
Okay, let's go back.
Cool. So there was like a parallel training scenario, right? Where you can run from. And then the last feature we'll kind of talk about is what we call native scoring. So far all the stuff which you saw is like either R or Python code running, doing training or scoring, right? So here this is something new in SQL Server 2017. So what we did is we took the Microsoft algorithms, right, the scoring part of it, and put them natively in SQL Server as a function. So we call that the predict function, right? So this is targeting high concurrent and low latency scoring scenarios. So that means like you have an insert statement, and as part of the insert statement itself, you want to run a machine learning model and generate some data, right? Scenarios are endless, right? Like for example, you have a credit card transaction and you want to basically score and say if it's a fraud or not, right? Similarly, you have some loan application which you're taking in and you want to assign some risk score, right? So those are the scenarios. So this one doesn't have any R Python dependency because it's running natively in SQL and it's our scoring part, right? So we don't have to call R and Python, so that's why it's much faster. And it can be used in any SQL query, so it's just a table valued function, right? So it looks like this. I mean, the top portion is just like how you get the model. It can be a simple SQL query. And in the bottom, the highlighted one which you see, the predict, that is a new table valued function. So just like in the R functions you would see, right, like all the R functions for the scoring will take a model and then data. Same thing here, you give it a model and then the data. The data can come from a table or a query, it could be a CT inside in the query, it could be a temporary table, any of these. And then it returns back a score, or it could be a classification, like depending on the model. And that's pretty much it. So in this example, we are basically taking that and inserting it into a table, right?
And you see, the models that we support, do we support all models in this, or?
Yeah, no. So this is, like I said, this is only the RX models. So there are about like I think 5 models which are supported here. So in the future we'll add more of our Microsoft models which you can train. So currently if you train using those 5 models, then you can use them for scoring.
And this is actually also available in Azure SQL Database.
Yeah.
So you can use this function in Azure SQL, and since it doesn't need to spin up R or Python processes, then it means that you can run this on SQL on Linux.
Yeah. So this is available on Linux also, so you can use that in Linux. Okay, so let's look at the model thing, the scoring. Yeah. Okay. So this is the procedure I kind of showed you, right? Like, so I have here a table. So this one, the database is, the scenario is some credit card transactions, right? And we are trying to determine if basically is there any fraud in that data or not. So that's what it is. Like, so there is like a transaction key, there is some, transaction amount, and then there are some risk values which are assigned to each one of those dimension values, like in this case, like where did the transaction originate and so on. So all of these columns are there, and this actually comes from a big table. Like in this case, I mean, I have a clustered column store. I mean, it's like a typical star schema kind of query, right? So now what we will do is, first let's see. So imagine I have to build a stored procedure which you want to score. I mean, this is how you, so now it's all SQL at this point, right? So you're not running any R, Python code. I mean, it's just a SQL query, right? So let's see how fast it can score a single row, right? So it's like a regular query, right? Like it's about 47 milliseconds in this case. So again, the performance of this function depends on the model. How many columns, like in this case I am sending like about 35 columns I think. How big the model is, the type of model and so on. So the latency for a single predict can be anywhere from 10 milliseconds to 50 milliseconds, 100 milliseconds. But what is the main benefit of doing this, right? So here I have the same piece of code, and basically I want to kind of demo like, okay, how fast is just the predict call going to be taking, right? So we'll tweak the input a little bit. So what we'll do is this one gets the model, right? And then we'll take 100 rows from that TVF, store it in a temporary table so that we don't have to keep repeating that big join, right? Because otherwise we are going to include the timing for the join also as part of your prediction. So we'll eliminate that piece. And then I'm going to do like 500 iterations. And I'm not going to insert into any table, so instead I'll just assign the value to a variable, right? This is the most kind of efficient way to kind of not consume the result, right? Because just going to keep assigning it to that variable. And then we'll time. I think the thing we want to demonstrate here is since it's a native SQL function, it will be very deterministic, right? So even, so I run this, like each one will take like about, I don't know, 24 milliseconds or something, I think. So each iteration. So this is going to run, and so that means like if I have like say 100 connections, I mean I'd still get like each one, there's almost the same throughput. So this one, like it's about like 23 milliseconds to score 100 rows, right? So I could do this as part of my insert, right? So now that was a different model. So now let's pick another scenario. This we demoed earlier in the conference. This is using a different model. So same thing, it's a complex query. We'll just save some of the rows. In this case, just one row. And we repeat the same exercise, right? We'll call the predict, and then we'll do same 500 iterations, right? I mean, in this case, like you can come here and SQL is not going to do much work. I mean, you just saw like few CPUs running, right? So this is about 13 milliseconds. So here you have the same function, but with different models and different input, and but the throughput will be essentially the same, right? So that's really the big advantage, and it's a SQL function. Cool.
All right, we're running out of time.
Yep, I think they're done. What is the last one?
Yeah.
Okay. So just to summarize, like, I mean, like, what are the things you want to kind of very high level, if you remember, I mean, these are the things, right, you can look at us, like, if you want to find out, like, hey, how long is it taking to send data and so on, we have a bunch of X events which will tell you, just like for regular SQL statements, right, like, you can find out, like, how much time SQL is spending sending data over to R, how much time R is taking to send the data back to SQL Server. So, and then a quick way to actually do this is to run this SP execute with your complex query, but no script at all, right? Like just empty script. All that is doing is sending data and then doing nothing and coming back, right? So that's a quick way to time. And then similarly CPU and memory, right? So this is one of the big piece of integration with this technology is how you can control both these resources from SQL Server, right? You can set up your policies, just like how you do RG today with any SQL workload, right? So we have this new external resource pool. The report actually showed some of the data from that. So you can use it to set CPU affinity. So on this big server, for example, when I run the benchmarks, I actually affinitize SQL and R to different CPUs so that they don't, you know, conflict on the resources. So those are things you can control, and these are very hard to do if you are doing your own R or Python development outside, right? And then memory is the other thing, so which you can tune. So you can tune it to use less memory, you can give more memory to R, so that's the other piece.
Yeah.
Summary?
So yeah, we hope that you feel that you have an overview of like what features are available now, how you can use them, and when they're applicable. We covered SQL compute context, we covered streaming, trivial parallelism for non-RX functions, parallel training and scoring for RX functions, and the native scoring. So you have really a good set of tools to be able to play with, to be able to get, optimize your machine learning scripts. So we have a bunch of resources. There's some links here and some tutorials. I don't know how many of you actually had used machine learning services in SQL Server, but if you haven't, we have some tutorials on aka.ms/mlsqldev. So those are like, we'll walk you through how to, do your first predictive modeling scenario or clustering, and also the links to the reports that we showed throughout the session. Yeah.
And the scripts will also be posted in the GitHub.
Yeah, we'll post the
can,
scripts. So the GitHub links are there, the R services and ML services. It's the Microsoft SQL Server GitHub repo. So we'll put everything there so you can access it. All right. Cool. Thank you.
That's it. Done. Yeah, and that's our email addresses. I mean, if you have questions, feel free to email us. And if you're interested in building something, you can reach out to us too, because we actually bring customers over to our labs and either do performance work on ML or actually just functional implementation. So we do that all the time.